Bushveld complex doesn't need a hell of a lot of introduction, I guess. What I'm going to talk about in these few minutes now is essentially the results of our geochronological work conducted by Simon Pepster, largely from BGS, and my PhD student Kate Abernethy, and on material, of course, from the flood reef, the Turfspreut, Ivanplatz flood reef deposit. Dani Grobler and Abi Britz were very important in this study too. Let me move, sorry, let me just move the pictures of the people out of the way here. So very briefly, Bushveld complex, most of you know what we're dealing with. The thing is the largest layered intrusion on Earth, 400 kilometers in north-south and east-west direction. There are four major lobes here, west, east, north, and a hidden lobe in the south, and also one in the far west here. The mafic, ultramafic layered intrusion really is this sort of olive green material here in color. And then we have granites and rhyolites too. Most likely the intrusion is connected at depth, but we don't have outcrop there and not enough geophysical information yet to be sure about that. We're going to look in this talk here now at the northern lobe, at the flood reef deposit, or the flood reef style mineralization, this contact style mineralization, PG mineralization. In particular here at the farm, Turfspreut, which is in the central sector of the flood reef. The only important thing that I want to briefly mention, because I think most of you know what we're dealing with here, is that in contrast to the bulk of the Bushveld complex, which rests largely on a relatively refractory quartzite, the Michalisberg quartzite, in the northern lobe, our mineralization here rests on floor rocks, on progressively stratigraphically deeper floor rocks when we move from south to north. So here in the south, we still, the Bushveld still rests on quartzite, then on shale, then on dolomites here, Malmani Formation, and finally on the Archean granite-gneiss basement. So it's the only really important area, or the main area of the Bushveld where we have where the igneous rocks cut down through the sedimentary sequence to lie on a range of country rocks, many of which are quite sulfide rich, and I think that's important in the origin of the mineralization. Yeah, the flood reef. So this is a sort of a very schematic picture here of the Bushveld, totally out of scale. Of course, it's much too thick. Also, the thing that might puzzle you here, and we're looking really at the lower critical main and upper zones here. The thing that might puzzle you are these sort of thickened reefs in the center. And this comes from years ago when I produced a schematic diagram based on what we found in the Kemi intrusion in Finland, where the chromite layers thickened from a few centimeters at the margins to 100 meters in the center. And I just sort of speculated that this might happen in the Bushveld too, but it's complete speculation. And probably I should not show what's happening in the center because we really don't know. But anyway, the focus of today's talk is the flood reef. And I want to use this picture to show you the setting of the flood reef. Really it's essentially the internal reefs, the Merensky and UG2 PGE reefs, that can be traced to the margin of the intrusion where the upper critical zone and these reefs essentially abut against the floor of the intrusion. That's what the flood reef really is. And the big enigma about the flood reef still is, and something we really don't understand, is the enormous amount of PGE that occur in this deposit. What do I mean? Well, this is a drill core profile, one of the many drill cores that Ivanplatz has drilled on the farm Turfspreut, and this is drill core TNT 006, one of the richest, this runs at 90 meters at 4.5 grams per ton, and there is the typical grade of the Merensky reef and thickness of the Merensky reef, so that gives you an idea of the gigantic, enormous mass balance problem that we're facing in the flood reef and the flood reef and how to explain it. Flood reef, by the way, what is a flood reef? Well, in the northern lobe, the contact style basal mineralization, we call it the Platte reef, and where the Platte reef at depth flattens on the farm Turfspreut in particular, potentially elsewhere too, we have this particularly thick, particularly high-grade mineralization. So that's where the name comes from, the flattened Platte reef, essentially. That's what the Platte reef is. And these stars, by the way, that's the samples that were selected for geochronological work, to which I come in a second. Right. So to understand how this thickened, how these thickness reforms, we can look at a couple of things. First, let's consider the origin of the layering in general in layered intrusions. I guess Wager and Brown, the original models basically suggested that what we're looking at is a rain of silicate crystals and perhaps sulfide liquid too, or perhaps as a result of magma mixing, then collected on the top of the cumulate pile. And there may have been some granular flow also on top of the cumulate pile to further concentrate the sulfides a little bit. That's what, for example, Irvine has suggested this at Skergarten, and we have proposed this for Bushveld and so on. So the question is this model a little bit too simplistic? One could suggest, and this is something I still believe in, is that the unusually thick PG reefs of the flat reef and flat reef form through hydrodynamic sorting of sulfidic crystal mushes. So some granular flow and kinetic sieving, separating smaller and larger and lighter and heavier crystals from each other, producing the layering here. That's one possibility. As I said, I still believe this has an important role to play in the Bushveld. And one of the reasons I say this is that when we look at the Plattreef, and here's a slightly more realistic or detailed profile across the Plattreef and Flatreef than the schematic one I showed earlier. And this one is based on the 700 kilometers of diamond drill core that Ivan Platz drilled on the property. So it's a fairly realistic picture, I think. And as you can see, the igneous rocks of the Bushveld here are in green, the main zone, and then the reds and purples, that's the upper critical zone. And then the sort of other darker green colors would be the lower critical zone and what they call the PNZ, which may be lower critical zone and the lower zone, of course. And so the important thing here is that the mineralized PG reefs are here shown in red, orange, and dark blue. And as you can see, they markedly thicker, particularly thick here in this trough-like, in this flattened portion of the flat reef, which we call the flat reef. So this seems to be some kind of a trough-like feature, and that's where the thickest mineralization occurs, and it's possible that's a result of hydrodynamic sorting. Now, the alternative, of course, is that some of these layers could have been in place as sills of PG-rich magma, and this sort of idea goes back quite a while. Lee and Butcher proposed it for the Mariinsky Reef years ago, and when you look at some of the layers in the field, and some of them do look like sills. Tawana Manyaruke in 2005 proposed that sills, that the Plattreef formed by the intrusion of sills, and there were several others who suggested a similar model. Judith Kinnaird here, Tersbroid, and Mitchell and Schoon and Akanani. And so this seems to be now gaining acceptance in the community, this sort of model. At the Flat Reef, Dani Grobler's paper in 2019 showed here, and this is of course again based on this enormously large diamond drill core database, showed they produced these sort of, what are they, grade shells of the deposit, and as you can see, the ore deposit, the mineralized layers clearly appear to be separated from each other by essentially barren horizons, which are shale horizons and calc-silicate horizons. So clearly a sort of a sill-like shape of the ore deposit that becomes increasingly clear when we look at the data. This is how these things may look like in drill core. So there's a sort of a 5-meter thick sill of pyroxenite, very sulfidic, here running at 6 grams per ton, hosted by thick shale pilitic horizons, layers several tens of meters thick. So this is clear evidence for a sill-like origin of the mineralization in the country. All right, and then of course in 2016, Jim Mangel really heated up the debate when he produced the first high precision geochronological data of the Bushveld, for the Bushveld, and suggested that he showed that there is an out of sequence ages of some of these layers. And there's been a lot of debate about this paper, a lot of criticism, a lot of support. There was a criticism by Latipov in the South African Journal, I think 2 years ago, where he tried to take the model apart. But what's clear, of course, is while there is some overlap in ages between many of these layers, when you look here at the MG2 the MG2 is clearly significantly younger than the UG1, the overlying UG1. So there is clearly some evidence for out of sequence ages in the Western Bushveld here. This data comes from the Western Bushveld complex. And this is high precision data. It's done by CID-TIMS analysis. So this is the standard really today, and all the dates that come out of the Bushveld now are using this technique. Yeah. Right. So what we need to do, of course, is to make sure to understand what this really means. Is we need to reproduce these results at another locality. Do these zircon populations of individual layers really capture simple histories, thermal histories, or are there more complex processes going on? And then, of course, what can we say about the timing of the flood reef relative to the Eastern and Western Bushveld Merensky Reef? There's been debate about that too. Is the flood reef the equivalent of the Merensky and UG2 or not? Right. So the data here. This is first. Here's a sample from the flood reef, the Merensky. What we correlate with the Merensky Reef and the flood reef, as you can see, 2056.2. And we also ran a sample from Northern Mine from Dave Reed of Merensky Reef. And as you can see here, there is very good overlap in the ages. So it does appear that the flood reef, the Merensky Reef horizon in the flood reef, some people call it the main reef, Marina Yurovskaya. So this sort of main mineralization in the flood reef is of the same age as the Merensky Reef in the Western Bushveld complex. And then, of course, we ran a number of other layers. So the main zone is the Bastard, what we correlate with the Bastard Reef. There is the Merensky Reef, the UG2, and then possibly the lower critical zone analog. And as you can see, indeed, if we just consider the oldest reproducible populations of these individual layers, then yes, there is clearly evidence for out of sequence pattern in these layers. So the other thing, by the way, that's really important, of course, is when you also look at the northern, particularly the northern Merensky Reef. Look at the enormous dispersion in ages here, more than 1 million years. So this is very interesting and a problem for us to interpret this. I'll come back to that in a second. Very, very large dispersion in several of these layers, and yes, out of sequence, it appears an out of sequence age pattern. What could be the reason for these things? Well, we considered
1 minute left.
1 minute. Oh, several models we considered. Firstly, age loss, lead loss, but we think the chemical abrasion technique largely excludes this. We could be looking at anticrystalline zircon populations, but zircon is not saturated in hot magma, so we think that's unlikely too. We could be looking at reactive flow, residual melts and fluids from below could percolate through the sequence and produce younger ages, but there are problems with this too, because you may have seen there was a recent paper on argon-argon dating on Bushveld biotites, and that showed that the intrusion cooled by about 1,000 degrees within 1 million years. So if we have an age dispersion of 500,000 years in a single layer, then that would, that would represent essentially a cooling of the intrusion to 500 degrees. And it's difficult to imagine how melts can percolate through an essentially solid intrusion. And then, of course, the SIL model. And the final possibility, of course, is that there is uranium isotope fractionation. This is something that Simon, our geochronologist, is very worried about, and it's possible that this could cover all the age variation that we see in all these studies. So this is at the moment unevaluated source of uncertainty. And I think I was, so the take-home message then is we clearly have SILs in the Bushveld. Well, it looks like we have SILs in the Bushveld complex, but the currently available geochronology and field evidence is not clear enough, not conclusive enough at the moment to tell us about the sequence of magma placement, I think, and we probably need to look at a much smaller scale at microtextures on a grain scale to get a better idea. I think I stopped here, although I have some more stuff. Good.